In this final video for Chapter 4, we want to talk about some things to be aware of and cautious with when you're doing LSR lines. But first, I want to talk about influential observations and outliers. Previously, when we were working with scatter plots, we talked about striking deviations, okay? And many questions came up. How are these different than outliers? How are they, how are they similar? And the answer is they are outliers. And formally, we could, do mathematics to show that we're not going to go that deep in this course. But the only other thing is that they could be outliers, they could be influential observations, or they could be both. So striking deviations can be an outlier, influential observation, or both. So what's the difference, right? An influential observation is by definition anything or any observation that changes the calculation of correlation significantly, okay? So to distinguish the idea, we're going to look at 3 models, okay? And in each model, I want you to look at this square dot, okay? It's kind of small. I'll highlight it so we're aware, okay? We would classify the square as an outlier in all 3 cases because it is far from all the other, or the main cloud of points, okay? So it's an outlier in all 3 cases, okay? But the question is it an influential observation or not, okay? So if we remove it or if we add it, either perspective, does it significantly change the model or the correlation that we calculate as a result? Okay, so here in this first model, you can see the solid black line is the linear, or is the LSR line we get using all the data. Okay, and then also the dashed line is what we would get if we removed the square dot, or the square observation, okay? And so here, to me, it changes the equation of the regression line a little bit, but not much. So in this case, I would say it is an outlier. An outlier. But this one, it does not appear to significantly change the regression line or the correlation. So I would just say it's an outlier only. Okay. Under model B, is this an outlier? Well, is it far from the cloud of points? I would say yes. So I would say it's an outlier for sure. And then in terms of an influential observation, does its removal or addition significantly change the correlation or the trend line that results? If I look at them and compare, okay, again, the solid line is the model with all the data. Dashed line is without this square observation. They do appear to be significantly different, okay? How significant we might have to quibble over, but they are different in a measurable way. So I would say in this case, this square observation is also an influential observation. Okay. Lastly, if I look at the data here and compare the 2 models again with the squared observation and without the square observation, they appear to be almost identical. Okay, so I would say this one, it does appear to be an outlier, but it does not appear to be an influential observation, meaning it does not appear to change the trend line or regression in any meaningful way. Okay, so just be aware of these terms, that any striking deviation that is far from the cloud of points, yes, it is probably going to be an outlier in all the cases, because you've already said it's noticeably different from the overall cloud, and the only question is it an influential observation? Okay, and then last case I want you to think about is, can you have an influential observation that is not an outlier? That's something I want you to consider. Okay, other final cautions with regression. Um, just as we talked about correlation not being resistant, um, given that it's very closely tied with the LSR line calculation, the LSR line is not resistant either. Okay, and a big thing is that when we talk about correlation and LSR, these describe linear relationships only. So if there's any sort of nonlinear pattern in our data, if you're using a line to describe it, shame on you. That's wrong. Okay, so linear relationships only. Okay, and then beware of confounding and lurking variables. In our previous work, we've actually defined these to be the same, but the textbook is pulling them apart. Lurking variable we defined as a confounding previously. Okay, the big difference in the definitions here is that a lurking variable is not originally considered in the study. Okay, whereas if you look at the definition of confounding, it is in the study. Okay, so this might, you truly could only have a confounding variable if you have multiple explanatory variables. Okay, and you might mix them. Okay, lurking variable is something that's not in the study, that is not being controlled for. Confounding is that it is in the study, but you can't separate it out in the response variable. Okay, so adjust those definitions as quickly and easily as you can. Okay, and so as we look at an example here, okay, this graph is modeling ice cream sales and weight, or average weight per capita. And so if you take a look at this, what confounding and lurking variables might be present here? I'll give you a moment to think. Here's my answers. So I said a lurking variable is climate because, well, if you think about it, at least in Minnesota, right, in the winter, where people are often heavier. So we're looking at blue as weight. So people are heavier in the winter as compared to the summer. They put on, they got to store up their fat for winter, and then they lose their fat over the course of a few months, and then put it back on. Similarly, ice cream sales low in the cold months, warm in the high months because ice cream just tastes better in the heat. So that's kind of one thing that could be lurking here that we're not accounting for. Confounding variable per this definition, at least I had a hard time coming up with an example because it isn't clear what else is or what other explanatory variables are in this study. Okay, so given it's just these two, there isn't a clear confounding variable, but just again, note the difference. Lurking variable is something that it influences the response that is not in the study. Confounding variable is a variable that influences the response in some way that is in the study. Okay, so it's connected to explanatory response, but you can't tease those relationships out.